In previous lectures, we have started with the point derivatives of the vectors with respect to the parameters. Now, what is meant by derivatives? Derivative is the dependence of one physical quantity with the another physical quantity. And in physics, almost all physical quantities depend on some another quantities. So, the derivatives of the vectors is necessary in a physics. In last lecture, we have seen velocity is a derivative vector of the position vector. Similarly, in this lecture, we are going to see acceleration. We know the formula for the acceleration. So, this A is nothing but the dv upon dt. Now, this is the velocity and this is the time. So, we can say that this acceleration is a derivative of the velocity with respect to time. Okay, we already know these formulas, but in form of a vectors we are going to study the acceleration. Now we can write the vector in a three-dimensional coordinate system. Like suppose this is a x-axis, this is a y-axis, and this is a z-axis, and these are the unit vectors along x, y, and z directions, which are I, j, and k. And this is I, j, k. Now suppose if there is any point, say P, and which is denoted by the radius vector r. So the position vector or the radius vector of this point P can be represented by, so this is r1i plus r2j plus r3k. So any vector in a three-dimensional coordinate system can be represented by its magnitude along x-axis into unit vector along x-axis plus magnitude along y-axis plus its into unit vector along the y-axis plus magnitude along z-axis multiplied by unit vector along z-axis. Now similarly, suppose if this point P is over here and it has moved to some distance, say P dash, and the position vector is represented by r dash, then the position vector of this r dash can be similarly given by, suppose this is r dash now, and say r1 dash is the magnitude along the x-axis plus r2 dash is the magnitude along the y-axis and r3 dash is the magnitude along the z-axis. Then the resultant vector r can be given by using the law of triangle of the vector addition. All these things we have already seen in the previous lecture, so I am not going to discuss it in details here. So you can watch my previous video also. So this capital R is can be, by using the law of triangle of the vector addition, we can write this small r plus this capital R is equal to this r dash, or we can write this capital R is equal to r dash minus this r. Now just put the values of this r dash and r over here. So we know that this vector r dash is nothing but r1 dash I plus r2 dash j plus r3 dash k minus r. So r is nothing but r1 I plus r2 j plus r3 k. So let me take these terms common. So I is common, here j is common, and here k is common. Okay, so r1 dash minus r1 into I plus r2 dash minus r2 into j plus r3 dash minus r3 into k. So these are the magnitudes. Here vectors won't come. So let me call this r1 dash minus r1 as delta r, then r2 dash minus r2 as a delta r2, and r3 dash minus r3 as a delta r3. Okay, so this is a dash. So putting these values in this equation, we are going to get r is equal to delta r1I plus delta r2j plus delta r3k. Now this is the position vector of the point which is giving the displacement of this point. Now this, I will call this r as a displacement. Okay, and once you know this displacement, you can calculate the velocity, yes, which we have already calculated. So this v was nothing but the derivative. So this velocity is a derivative of this position vector with respect to time. From this equation, so this d by dt of this position vector dri d delta r1 I plus delta r2j plus delta r3 k. So this is nothing but, so this v can be written as vxi plus vyj plus vzk. This we have already seen in a previous lecture. From the definition of the acceleration, we know that this acceleration is nothing but the derivative of the velocity with respect to time. Now putting the value of this velocity into this, so this d by dt of, so this vxi plus d by dt of vyj plus d by dt of vzk. Now if I put this limit delta t tends to 0, d by dt of vxi plus limit delta t tends to 0, d vy upon dt plus limit delta t tends to 0, dvz k upon dt. So this term is nothing but derivative of the velocity vector with respect to time along the x-axis. This is the velocity vector with respect to time, and this is the velocity vector with respect to time. So this is nothing but the acceleration. So this acceleration can be written as, so this is ax, then this is ay, and this is az. So the acceleration or the total acceleration can be given by addition of the acceleration along x-axis, along y-axis, and along z-axis. All the physical quantities which we study in physics, they almost all are the derivatives with respect to some another parameters. Like velocity is a derivative of the radius vector with respect to time. Acceleration, which we have seen just now, so acceleration is a derivative of the velocity with respect to time. So this angular velocity is the derivative of this angular displacement with respect to derivatives of the vectors with respect to parameters is the most important point regarding physics.